In this lesson, we're going to go over variation. Specifically, we'll review the range and the 5-number summary. We'll use the 5-number summary to create a box plot or box and whisker plot. We'll understand and calculate standard deviation, and then we'll talk about the range rule of thumb. So variation describes how widely data values are spread out over the center of the data. So these distributions going from left to right have increasing variation. So with low variation, the values are pretty concentrated around a certain point. Moderate variation and then high variation, the values span over a wider range of values. So review: the range is your span of the data set. It's your max value minus the minimum value, or highest minus lowest. The 5-number summary, it actually breaks the data set up into quarters. And so just as a review, the minimum is the smallest value, the lower quartile is the median of the lower half, the median is the median of the entire data set, the upper quartile is the median of the upper half of the data set, and your max is your largest value. This divides your data into quarters as follows. So the median, or the lower quartile, the median, and the upper quartile, there's 1, 2, 3, 4 quarters. Okay. So making a box and whisker plot. So you can make a box plot or a box and whisker plot using the 5-number summary. In fact, that is what you use. So there are some steps here, and then I'll demonstrate this on the next slide. So draw a number line that spans all values in the data set first. Draw a line for the median, a line for your lower quartile and upper quartile. And by connecting these lines to the median, you'll have your box. And then you'll draw a line for your min and your max, and you'll connect those boxes to those values. So you'll end up with a box with some whiskers. Okay? So for example, find the 5-number summary and draw its corresponding box plot. So on this slide, we'll do the 5-number summary, and on the next slide, we'll do its box plot. Okay, remember, always make sure your values are ordered smallest to biggest. So I'm going to copy those down here. Okay, so remember, your minimum value is your smallest value. Our lower quartile, I usually do median, upper quartile, and then the max. Your max is your highest value, and your median is what cuts the data set in half. So again, cross off values as you go, and you'll end up with your median at 77. Okay, and so from here now, this splits the data set into 2 halves. So I split the set, and now I have the lower half. Okay, and so to find the lower quartile, you take the median of the lower half. The lower half in this case falls in between 66 and 72. So you add them up and divide by 2, and we should get 69. And then your upper quartile is the median of your upper half. In this case, it's 82 and 82 in the middle, so halfway between 82 and 82 would stay as 82. Okay. So now what we'll do on this slide is we'll use those values, the minimum, the lower quartile, the median, the upper quartile, and the max, to draw our box and whisker plot. So our smallest value is 55, so I'll probably start my number line at 50, and our largest value is 80, so I'll probably go up to 90 and then go in increments of 5. Okay, and so the first couple of steps are we draw a line for the median. Our median's at 77. Then we draw a line for the lower quartile, which is 69, and the upper quartile, which is 82. Okay. And then in step 3, we're going to box those in. Okay. So now we have our, well, that line should stay there. Median, okay. Okay, and then next we draw a line for the minimum, which is at 55. Oops, I think I said I was going to start at 50. And then our max is 88, and then that makes our whiskers. So our box essentially boxes in the lower quartile to the upper quartile with a line drawn for the median, and then your whiskers are your min and your max that span out from the box. Okay. Standard deviation. So standard deviation is a single number that describes how far data values are from the mean. So what I'm going to do is we're going to eventually go through an example calculating this by hand. And then in another video, I'm going to do a demonstration using Google Sheets, since we all have access to that through our Rebel Mail, or since our university emails are on Gmail. And I'll show you how to calculate like mean, median, and standard deviation using Excel. Google Sheets, by pasting the values you're given in the homework into there. Okay, so the standard deviation is the square root of, there's a numerator and denominator, and the numerator is the sum of derivations from the mean squared, and then the bottom is your total number of values minus 1. And so what we'll do in the next slide is I'm going to break this formula down, talk about steps to calculating standard deviation, and then we'll go over an example. So in order to calculate standard deviation, you need to find the mean of the data set. Notice how part of the formula is derivations from the mean. Once you find the mean, you take each data value, subtract the mean from it, and then you square that number. You add all of those squares together, which is what sum of derivations from the mean squared is referring to. You divide this by the total number of data values minus 1, and then lastly, take the square root of that number. So we have a data set here, 2, 5, 7, 8, 11, and 12. Okay, so the first step is to find the mean, and I'm going to do it up higher just so that I leave myself room. You would add up all these values and divide by the total number to get, you should get 7.5. Okay. So the second step is we take each data value minus the mean. So we take 2, 5, 7, 8, 11, and 12, and we're going to subtract the mean from all of those. Okay, it's okay that these are going to end up negative, because when we square them, multiplying a negative times itself, which is also negative, will give us a positive. So this first one gives us negative 5.5. This is negative 2.5, negative 0.5. This would be positive 1.5, or actually, sorry, this is just positive 0.5. That one is also 0.5, and then we have 3.5 and 4.5. Okay, so this is step 2. Now in step 3, I'm going to do it in a different color, but what we'll do is we'll end up squaring all of these values. And so I will write those in green. So negative 5.5 squared is 30.25. Negative 2.5 squared is 6.25. Negative 0.5 squared is 0.25. 0.5 squared is 0.25. 3.5 squared is 12.25. And then 4.5 squared is 20.25. Okay, so that's step 3. Now in step 4, what we do is we add all these together. So let me get a different color. Step 4, you would take 30.25 plus 6.25 plus 0.25 plus 0.25 plus 12.25 plus 20.25, and we come out with 69.5. In step 5, we divide by the total number of data values minus 1. So in this case, 69.5, divided by 6 minus 1, or just 5, and we come out with a long decimal. So you can leave that number stored in your calculator. There's a couple different ways to do it from here, because the final step is to take the square root of this number. So what you could do is on the Texas Instruments to find the square root button, it's in like a lighter color here. So in order to call it from the calculator, you need to use the second button and then press X squared. Let me take a look at the Casio. You can tell which calculator I use. The Casio just has a square root button here. So you can use that square root button and then type in this fraction if you want. So let me show you what that would look like. Square root 69.5, square root, then fraction, 69.5. And then divide that by 5. And you'll get about 3.728. So that's how it should look in the calculator. If you're using the Texas Instruments, you'd press second and then the X squared button. and it automatically puts a parenthesis there for you. So you do 69.5 divided by 5. Close your parenthesis, so it should look like that, and then click enter. So the standard deviation, you put that in, you take the square root, this would be about 3.73, and it'll tell you where to go. Okay, like I said, I'll show you how to do this in your calculator, or I did show you how to do this in your calculator by hand, and then I'll do another video using Google Sheets. Application. So what does standard deviation tell us? So let's say each night you total the day's sales and total volume of ice cream sold in your shop. When employee A works, the mean price of ice cream sold is $3.10 per pint with a standard deviation of 35 cents. When employee B works, the mean price of ice cream sold is $3 per pint with a standard deviation of 7 cents. What is going on here? Okay, so picture it, you're in an ice cream shop, you're filling pints of ice cream. If you have a big standard deviation like employee A does, chances are you're probably shortchanging the pint. It's hard to overfill a pint and still put a lid on. You're probably giving customers less. So maybe as a boss, when you get complaints, that could tell you something too, using the mean and standard deviation. Employee B, pretty consistent, $3 on average with a standard deviation of 7 cents. Not a lot of wiggle room going on there. Last thing that we'll talk about is the range rule of thumb. And what this does is it uses the range to estimate standard deviation, and it really only works when there are not a lot of outliers. Okay, so our range rule of thumb is that our standard deviation is about equal to the range divided by 4. So if we apply this rule to the data set that we use for standard deviation, we would take our range, or our standard deviation, is approximately equal to 12 minus 2, which is the range, the highest minus the lowest, and divide that by 4, which would give us 10 over 4, which is about 2.5. Okay, so that's how the range rule of thumb is used. If you have any questions, please feel free to reach out to me, and make sure you check out the video about using Google Sheets for these numbers as well.